Look at the room around you. Now look up at the night sky. The observable universe contains over 2 trillion galaxies. Now, imagine shrinking the Earth, the Sun, and all those galaxies into a space millions of times smaller than a single atom. Welcome to T-0. The very first tick of the cosmic clock. This is the absolute beginning of our reality, 13.8 billion years ago. Here is a scientifically verified fact: the Big Bang was not a chaotic, colorful firework burst erupting into an empty void of space. There was no outside space to expand into. Instead, it was the breathtakingly ordered, mathematically perfect expansion of space itself. We are now in the Planck epoch. The first 10 to the power of minus 43 seconds. A slice of time practically unimaginable. The temperature is a blistering 100 million trillion degrees Kelvin. The standard model of particle physics tells us it's pure chaos. At this microscopic scale, everything we know completely breaks down. The familiar laws of physics, gravity, and quantum mechanics are entirely rewritten and meaningless. Theoretical physicists speculate this realm is a quantum foam. An intensely energetic bubbling soup where microscopic wormholes swiftly open and seal shut instantly. In this bizarre extreme environment, the very concept of time is fluid and unstable. Moving forward, backward, or standing still means absolutely nothing here. Scientists hypothesize that right now, the 4 fundamental forces of nature, gravity, electromagnetism, and the nuclear forces, are fused into one single superforce. We are operating at the Planck length. You can think of it as the absolute minimum pixel size of the cosmic simulation. What happened before this exact fraction of a second? We honestly do not know. Our best mathematical equation simply hit a wall. But the universe is a restless entity. It cannot remain this incredibly dense, hot, and unified for long. Something has to give. Gravity is about to dramatically separate from the superforce. And the very fabric of space is about to expand at a speed that defies all logic. At 10 to the power of minus 36 seconds, an event called cosmic inflation begins. The young universe hits the ultimate gas pedal. Proposed by physicist Alan Guth in 1979, this theory solves the biggest mysteries of the Big Bang. But it requires breaking the cosmic speed limit. Nothing travels faster than light through space. But space itself? It doesn't have a speed limit. The very fabric of reality simply stretches outward. In a fraction of a microsecond, the universe expands by a factor of 10 to the 26th power. A number so large, it defies human comprehension. To put that in perspective, imagine a single subatomic proton suddenly expanding to the size of our entire solar system, in less than a blink of an eye. Why did the universe do this? Astronomers realized that without this dramatic, rapid expansion, our cosmos wouldn't make any mathematical sense today. Look at the night sky. In completely opposite directions, the background temperature of deep space is exactly the same, down to the 5th decimal place. How could 2 regions, billions of light years apart, share the exact same temperature if they never had time to interact? This is called the horizon problem. Inflation is the perfect answer. Before this rapid expansion, everything was compressed together in a tiny microscopic point, perfectly mixing the cosmic soup to the same temperature. Then, inflation grabbed that perfectly mixed soup and stretched it dramatically across billions of light years, locking in that uniform temperature everywhere across the grid. It also solves the flatness problem. The universe appears mathematically flat. If it were highly curved, galaxies simply wouldn't form the way we see them today. Imagine an ant on a small balloon. It sees a tight curve. But inflate that balloon to the size of the Earth, and the surface looks perfectly flat. During this dramatic stretching, tiny, microscopic quantum fluctuations, the chaotic bubbling foam of the universe, were permanently frozen and stretched to massive cosmic scales. These stretched quantum ripples became the absolute blueprints for everything. They are the dense seeds that will eventually collapse into the cosmic web, galaxies, and stars. At 10 to the minus 32 seconds, inflation stops. The expansion energy transforms, dumping colossal amounts of heat, creating the true primordial soup. We have officially entered Act 2. The universe has drastically slowed its expansion, transforming all that kinetic energy into a dense, blistering primordial soup. This glowing plasma fog is so immensely dense and frictionless that even pure light cannot travel through it. It's the ultimate cosmic traffic jam. As the universe expands, it begins to cool. And in physics, cooling leads to a profound transformation called symmetry breaking. Think of liquid water freezing into distinct ice crystals. As the cosmic temperature drops, the perfectly unified laws of physics begin to crystallize and separate. Gravity has already separated. Now, a fraction of a microsecond in, the grand unified theory divides. The strong nuclear force energetically detaches. This red, intensely powerful energy stream is the cosmic glue. It is the vital force that will eventually hold atomic nuclei together. Without the strong force locking things down, protons and neutrons would simply repel each other, and solid matter as we know it could never exist. But we aren't done. The two remaining forces, electromagnetism and the weak nuclear force, are still beautifully intertwined into a single electroweak superforce. The clock ticks to 10 to the minus 12 seconds. The ambient temperature plunges to a freezing 10 quadrillion degrees Kelvin. And then, the final great split occurs. The electroweak force beautifully uncoils, dividing into the electromagnetic force and the weak force. Electromagnetism gives us light, magnetism, and chemistry. The weak force governs radioactive decay and allows stars like our sun to burn. The fundamental architecture of reality is now permanently locked in. The four forces of nature have officially taken their distinct forms. These invisible rules now govern everything. But despite having the rules in place, the universe is still far too hot to build anything solid. Protons and neutrons haven't even been created yet. The cosmic kitchen is fully prepped, and it's time to prepare the ingredients. Welcome to the Quark Epoch. The universe is now a frictionless, blindingly hot ocean of free-floating fundamental particles, moving at near light speed. For every single particle of matter created, an identical antiparticle is born. They are perfect mirrors. But they harbor a fatal intolerance for each other. When matter and antimatter touch, they instantly convert 100% of their mass into pure, blinding radiation. A process called annihilation. At 10 microseconds, the universe begins to cool. New particle pairs can no longer be created from the ambient heat. The great cosmic cancellation begins. This brings up a terrifying hypothesis. If the universe was perfectly symmetrical, every single particle would have found an antiparticle to cancel out. The result would be an immensely boring universe filled with nothing but freely traveling photons. No stars. No galaxies. No planets. No us. But nature is wonderfully, beautifully imperfect. Physics tells us about an event called baryogenesis. A fundamental glitch in the cosmic code. For reasons scientists are still desperately trying to figure out, there was a tiny, minuscule imbalance in the exact numbers. For every 1 billion particles of antimatter, the universe mysteriously created exactly 1 billion, and 1 particles of regular matter. And so, the Great Annihilation ran its course. A colossal, universe-wide flash of pure radiation as nearly all particle pairs gracefully dissolved into light. When the blinding flash finally cleared, the antimatter was entirely gone. Erased from existence. But floating alone in the sea of light. What remained was that incredibly lucky leftover particle of regular matter. The 1 in a billion survivor. It is all made entirely from these rare, leftover survivors. You are literally made of the 1% of a percent that refuse to disappear. Now, the antimatter is gone. The quarks are alone. And as the universe continues to expand and freeze, it's time for them to finally bond together. We are now exactly 1 microsecond after the beginning. The universe has expanded immensely, and the chaotic quantum storm is finally calming down. The free-roaming quarks are losing their kinetic energy. The strong nuclear force, acting like cosmic glue, finally has enough grip to reel them in. Think of quarks as the universe's ultimate Lego bricks. They come in a few different types, but the most important are the up and down quarks. The strong force acts like an unbreakable rubber band, snapping 2 up quarks and 1 down quark together into a tight, permanent bundle. And just like that, the very first proton is born. This tiny, indestructible structure will eventually become the stable heart of every single atom. Meanwhile, a different combination, 1 up quark and 2 down quarks, fuses elegantly to create the proton's neutral sibling, the neutron. These new, incredibly stable structures are called hadrons. For the first time, the universe contains solid, persistent mass instead of just a free-flowing liquid. Trillions upon trillions of these protons and neutrons are manufactured across the cosmos in a fraction of a heartbeat. The cosmic soup is thickening rapidly. Exactly how thick is this new mixture? Well, if you could somehow reach out and scoop up a single teaspoon of the universe at this exact moment. That single glowing teaspoon would weigh over 500 million tons. Roughly the weight of a massive mountain range. The density is absolutely staggering. But the universe does not stop to admire its new creations. It continues its relentless, silent expansion. And then, we finally hit the most profound milestone yet. The cosmic clock strikes exactly 1 full second. Happy first birthday to the fundamental laws of physics. We survived the absolute chaos of the beginning. At this historic 1-second mark, the ambient temperature of the cosmos has plummeted to a relatively chilly 10 billion degrees Kelvin. It is now officially too cold for any new protons or neutrons to be spontaneously created from energy. The final inventory of the universe is permanently set. The basic building blocks are ready. The stage is perfectly set. But hold on tight, because the entire universe is about to ignite into the largest nuclear fusion reactor imaginable. We now fast forward from 1 second to exactly 3 minutes after the Big Bang. The entire universe essentially becomes the core of a massive, superhot star. The temperature is still a blistering 1 billion degrees Kelvin. It is so intensely hot and dense that protons and neutrons are being violently smashed together. When 1 proton and 1 neutron energetically collide and stick, they form the very first isotope, deuterium, a heavy form of hydrogen. But there's a massive problem. The surrounding light particles, the photons, are still so fiercely energetic that they instantly blast the deuterium apart. This frustrating cycle is called the deuterium bottleneck. The universe essentially has to wait for the space to expand and the photons to cool down just a little bit more. Finally, the temperature drops below 1 billion degrees. The bottleneck breaks. The photons are too weak to destroy the bonds, and a frantic chain reaction begins. The deuterium pairs quickly sweep up more protons and neutrons, fusing together into an incredibly tight, incredibly stable cluster of 4, the helium nucleus. For every one of these golden helium nuclei forged, there are roughly 12 single, lonely protons left over. Those single protons are what we simply call hydrogen. But this spectacular cosmic forge doesn't last long. The universe is relentlessly expanding, thinning out, and plunging in temperature. At roughly 20 minutes after the Big Bang, the temperature drops too low. The era of nucleosynthesis violently snaps shut. No more elements can be forged. The final inventory of the early universe is locked in. By mass, it consists of 75% hydrogen and 25% helium. There is also an incredibly tiny, almost microscopic trace of a third element. A complex cluster of 7 particles known as lithium. If you looked at a periodic table right now, only the first 3 slots would be filled. Every other element, from oxygen to carbon to gold, does not exist yet. Here is the most mind-blowing fact: when the James Webb Space Telescope looks at the oldest, most pristine gas clouds in the universe today, the ratio perfectly matches this exact math. The universe is now filled with atomic nuclei. But it is still a thick, blindingly bright plasma fog. Because the electrons are still running wild, and light is completely trapped. For the next 380,000 years, the universe is stuck in a frustrating state. It is officially known as the opaque era. If you were floating here and turned on a flashlight, the beam wouldn't travel across space. It would instantly scatter, bouncing right back into your eyes. This is called Thomson scattering. The universe is absolutely swarming with hyperactive, free-floating electrons. They act like a chaotic cosmic pinball machine. The atomic nuclei, the protons and helium cores we just forged, are sitting right there. But the universe is still too hot for them to capture those electrons. So, the cosmos simply has to wait. And expand. 10,000 years pass. Then 50,000. Then 100,000 years. The universe slowly stretches out. It's a staggeringly long, uneventful period. Just a continuously expanding, cooling, glowing wall of gas. Nothing new is being created. Nothing is being destroyed. As space physically expands, it stretches the wavelengths of the trapped light along with it. The ambient color shifts from a searing white, down to orange, and finally towards red. Finally, we reach the 380,000-year mark. The cosmic thermometer drops to a critical threshold, exactly 3,000 degrees Kelvin. At this specific temperature, the chaotic kinetic energy of the universe is finally exhausted. The hyperactive free electrons begin to slow down. They are now moving slow enough for the electromagnetic force to finally take over. The protons and helium nuclei reach out with their positive charge. This is the moment. The most beautiful phase transition in the history of the cosmos is about to trigger. With a graceful cosmic click, the first electron falls into a perfect orbit around a proton. The very first true atom of hydrogen is officially born. This event is called recombination. And it doesn't just happen once. In a sweeping, universe-wide chain reaction, every single electron is suddenly captured from the fog. Because the electrons are now locked away safely inside atoms, they are no longer flying around to block the light. The cosmic traffic jam is instantly cleared. And for the very first time in 380,000 years, the universe becomes completely transparent. The trapped light finally breaks free, rushing outward across the infinite cosmos. That ancient, brilliant flash of light has been traveling through space ever since. Unstoppable. But as the universe continued to physically expand, it did something fascinating to the light. It stretched the light waves like a cosmic rubber band. The light shifted from visible red, all the way down into the invisible microwave spectrum. This is called redshift. Because of this, the sky appears black to our naked eyes. But if your eyes could see microwaves, the entire night sky would be glowing brilliantly with the leftover heat of creation. In 1964, 2 astronomers named Arno Penzias and Robert Wilson were testing a massive radio antenna in New Jersey. They kept picking up a persistent, annoying background noise. They hadn't found a broken machine. They had accidentally stumbled upon the holy grail of cosmology, the cosmic microwave background. The absolute proof of the Big Bang. But you don't need a massive radio telescope to see it. If you've ever turned on an old analog television and tuned it to a dead channel, that chaotic snow on the screen is mostly local interference. But exactly 1% of that static is the ancient radiation from the Big Bang actively hitting your antenna. Decades later, advanced satellites mapped this entire glow. What they found was the most important image in human history, the baby picture of the universe. Those tiny color spots represent microscopic temperature differences. They are the exact quantum seeds we saw earlier, which eventually collapsed into the vast cosmic web of galaxies. The universe spent the next 13.8 billion years continuing to expand, cooling down from a blistering furnace into a freezing, breathtakingly beautiful void. It forged stars, planets, and eventually, the very atoms that make up your body. You are not just a creature living in the universe. You are the universe itself, finally waking up after 13.8 billion years, and figuring out a way to look back at its own magnificent creation. The Big Bang wasn't just an explosion in space. It was the birth of space, the ignition of time, and the breathtakingly perfect origin of you. Thank you for joining this cosmic journey. Keep looking up, and never stop wondering.